Let's be honest, we're surrounded by numbers. They're everywhere. News headlines, your fitness app, the stock market. It's just a constant flood of data. But on their own, what do they really mean? They're kind of just noise, right? Well, in this explainer, we're going to learn how to turn that noise into a story using the powerful language of statistics. So, take a look at this. It's a list of ages. What does it tell you? Yeah, pretty much nothing. It's just a jumble of numbers. This is what we call raw data. And trying to find any meaning in this is like being dropped into a dense jungle without a map. It's confusing, a little overwhelming, and honestly, not very useful. But what if there was a way to organize this mess? A set of tools that could find the hidden patterns and make the story just jump right off the page? Well, you're in luck. That's exactly what statistics is for. It's the secret language that makes data speak. So what is statistics really? At its heart, it's a complete toolkit for making sense of the world. You collect your raw materials, that's the data, and this toolkit helps you shape it, analyze it, and show it to people in a way that leads to smarter, clearer decisions. Okay, so where do we even start? Well, the first step in telling any story with data is to find its main character, its central point. We call this finding the central tendency. It's all about answering a simple question. What's a typical value here? The most common tool for this is the mean, and you almost definitely know this one. It's just the average. You just add everything up, divide by how many numbers you have, and boom, simple, straightforward, and a really great starting point. Next up, we have the median. Now, this one's all about position. You literally line up all your numbers from smallest to largest, and the median is the one that's smack dab in the middle. Half the data is smaller and half the data is bigger. That's it. And finally, there's the mode. This one is the easiest of the bunch for sure. It's simply the value that shows up most often. Just think of it as the most popular kid in the class, the most common number in the group. So, okay, we've got 3 different tools to find the center. But here's the catch, and it's a big one. They are not interchangeable. Choosing the wrong one won't just give you a slightly different answer. It can flat out lie to you. Let me show you what I mean. Let's look at a really simple example. Here we have the salaries for 5 employees at a small company. Everything looks pretty normal, right? They're all kind of clustered between about $50,000 and $65,000. Seems reasonable. Now, if we calculate the mean salary, the average for this group, we get $58,000. And that feels about right, doesn't it? It's a pretty good representation of what a typical employee at this company earns. No surprises yet. But now, watch what happens when we add the CEO's salary to the mix. That $1.15 million is what we call an outlier. It's an extreme value that's completely different from the rest of the group. And whoa, all of a sudden, the average salary skyrockets to nearly $300,000. Now, if someone told you the average salary at this company was that high, you get a completely false picture of what most people there are actually taking home. In that, right there is the mean's biggest weakness. You could even call it its kryptonite. It is incredibly sensitive to these outliers. Just one single extreme number can pull the average so far away from the center that it becomes basically useless for describing a typical person's experience. But now, look at the median. It's $59,000. It barely even budged. And why is that? Well, because the median doesn't care how massive that top number is. It only cares about which number is in that middle spot. This is exactly why when you hear about things like house prices or income, you'll almost always see the median value reported, not the mean. It's just a much more honest number. Okay, so finding the center is a crucial first step, but it's only half the story. Just knowing the average doesn't really give you the full picture. We also have to ask, how spread out is the data? Are all the numbers packed tightly together, or are they all over the map? Take a look at these 2 groups of numbers. Believe it or not, they both have the exact same mean, 200. But they're telling completely different stories, aren't they? Dataset A is perfectly consistent. Every value is the same. Dataset B, on the other hand, is all over the place. The mean, by itself, completely misses this massive difference. This whole idea of variety or consistency, well, it has a name. It's called dispersion. It's just a way of measuring how much the data points disperse or spread out from that central value. Are they huddled together, or are they scattered far and wide? And the most powerful tool we have for measuring this is the standard deviation. Now, try to think of it like this. It defines a zone of typicalness around the mean. A small standard deviation tells you that most of your data is really close to the average. A large one tells you that the data is much, much more spread out. Here's a great way to picture it. On the left, with that small standard deviation, the data is all tight and predictable. On the right, with a large standard deviation, the values are super variable, scattered across a much wider range. Okay, so we found the center and we've measured the spread. There's just one last piece to our statistical story: understanding the overall shape of our data. This shape is often described by something called skew. If your data is perfectly balanced, it's symmetrical, and the mean, median, and mode will all be pretty much the same. But remember our CEO's salary example? That one gigantic outlier pulled the mean way over to the right. That created what we call a positively skewed distribution. The long tail of data was on the right. And the opposite can happen too, a negative skew, when super low values pull the mean to the left. So, we've covered center, spread, and shape. And I know, it might feel like a bunch of abstract math concepts, but they're not. They're actually powerful lenses you can use every single day to be a smarter, more critical thinker. Think about it. Next time you read about average house prices, you can stop and ask, wait, is that the mean or the median? Because now you know that a few mega mansions could be totally distorting that number. Or when you see a product with a 4-star average, you can wonder, is that mostly 4-star reviews? Or is it a bunch of 5-star and 1-star reviews just canceling each other out? Asking these simple questions gives you a much, much clearer picture of reality. You now have the fundamental tools to look past the flashy headlines and understand the story the numbers are actually trying to tell you. The world is full of data, just waiting for someone to make sense of it. The only question left is, what story are you going to uncover next?